And here you are seeing a PDF file. Are you seeing this?
Yes.
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 So this is the first problem that we want to solve, and hopefully we can cover the materials related to the all 4 chapters. So the first one is the velocity of a particle is given by v equal to at square plus b by a t, where v is in meter per second, t is in seconds, and we need to determine dimensions of b. So can someone tell that regarding dimensions, I used to give you one example all the time, and here I'm repeating that again, that if we have velocity on the left side and the right side, there are 2 different terms which are added. So at square, that's one term, b divided by a times t, that's another term. So what do you think? What should be the unit of at square?
Should be
L over T.
Should be meter per second,
per
right?
second.
And what should be the unit of b divided by a times t?
Unit
Also
meter per second.
Also meter per second. So that should be established. Whenever you are looking at any equation, what the quantity is seen here, whatever the unit of that is, the remaining terms which are added or subtracted in the equation, they should have the same units. Okay. So here at square, since the b divided by a times t, there are 2 unknowns in that term, so I will just get the at square, which is the first term, and there is only one unknown for me. So I will begin with that to determine the unit of a, and we know that the unit of this is going to be meter per second, because it is in the equation of the velocity. So I divide both sides by t square. It will be meter per second and t square, and I'm putting the units of t now. We know it is going to be seconds from here and second square from here, so it will be second cube. So this is the unit of a. Now I go to the second part and I say that b divided by a times t, it is also going to give me the units of meter per second. But I want to make this b alone, so I'm multiplying both sides by a and dividing both sides by t. So b is going to be meter per second times t multiplied by a. Okay? And then now I will be putting the units of these variables. Meter divided by seconds and seconds, so it will be second square. And we also know the unit of the a from here, it is meter per second cube. If you collect all the units, then you will be seeing that the unit on the numerator, it is meter square, and the unit in the denominator, it is s power 5. So what is the symbol that we use for the meter?
L over T. L.
L. So L square divided by T, capital T, power 5. So if you write this in the denominator, it will be power 5. If you remove this to the numerator, it will be minus 5. That's the only difference afterward you can make. Here I'm going to give you one quick example. I don't want to spend more time on the dimensions, but you should know this. If it was given to you sine theta, okay? But instead of theta, they are giving you something like time t divided by a, like this. It is sine theta, it could be cosine theta, tangent theta, any other trigonometric function. Sine theta, t divided by a. And they ask you to determine the dimension of a. What should be the dimension of a?
0.
Can someone else answer this question?
Maybe T.
Maybe t, yes, because when you look at the theta is degrees, and degrees means no units, right? It's just the unitless quantity. So whatever the quantity you have in the numerator of a fraction, the same quantity will go to the denominator. And you may have often observed that whenever we are determining the dimensions, the direction of any vector quantity, and we say tangent inverse, and then the y component divided by x component. So if the y component has kilometer unit, then the x component also has kilometer unit, which cancels out. So at the end, the argument of the sine, cosine, tangent, or any other trigonometric function should be unitless. That's one thing to be noted. Another related example for the dimensions is that if you have exponent e, and then the power of that is t divided by a, okay? Again here, what should be the unit of a?
Second.
Second over
Seconds again, because here again, whenever you have something in the arguments of the exponential function, either it could be written as e, or it could, sometimes they also write it as exp, exponential function. And in the arguments, they provide you t divided by a. Whenever you look at this kind of function, this thing has to be a number, okay? The argument has to be a number. So therefore, the unit you have in the numerator, it should be the same in the denominator. So at the end, the two units cancels out and you get a number with no units. Okay, let's go on to the second problem. So in this, the position of a particle as a function of time is given by this equation, where x is in meter, t is in seconds. Find the velocity at a time when the acceleration is 0. So it's a very straightforward question if you look at that. So here we have x, it is 3 t cubed minus 10 t square plus 9t. One thing, guys, if you notice that I'm going a little bit fast, then tell me that slow down so that I can get into your mode, okay? So this is the displacement, and here, whenever we want to determine the velocity, then we take the derivative of this with respect to t, which is dx by dt. So I'm applying the derivative directly. Can someone tell what the first term will become?
60.
90 square
90 square
minus
minus 20t
minus 20t plus
9.
9. And then the acceleration, what will happen to acceleration if you take again another derivative?
18t minus
It will
20.
be 18t
Minus
minus 20. Okay.
Yes.
So they are saying, if you read the statement, they say find the velocity at the time when the acceleration is 0. So here we determine the acceleration and we make it 0. Okay, we make it 0 because that's where we want to determine the velocity. So when we make it 0 and solid for t, we see that it is going to be 20 divided by 18 and seconds, because they are saying us in the problem the unit of t is already seconds here. So 20 by 18 seconds, this is the time. Now we need to determine the velocity. All we are going to do is to take this and put in the velocity. So 20 divided by 18 square minus 20, again 20 by 18 plus 9. And that will be, whatever you get, that will be our answer. This is a very good problem, guys. Just pay attention to it because it looked to me it's an unusual pattern. Most of the time, students don't see this kind of problem. The position time curve for a particle moving along x-axis is shown in this figure. The dashed straight line are tangent to the curve at t equal to 1 second and t equal to 3 seconds. Find the magnitude of the average acceleration in the time interval t equal to 1 second and t equal to 3 seconds. So when you are interested to determine the average acceleration, can someone tell me what will be the equation for that? For the average acceleration?
Delta V over delta T.
Delta V over delta T. Yes, you can write that as delta V over delta T, or you can also write that as V2 minus V1 divided by T2 minus T1. Okay. Since the time interval they are asking us T1 and T2, we know it. So T1 we can assign for 1 second and T2 we can assign for 3 seconds. But can someone tell what is the acceleration at T equal to 1 second?
What
is the velocity? Yes, sorry.
We need to take the slope of the tangent.
Yes, we need to get the slope of this. That's an excellent answer. So here we need to have V1. And for V1, we need to take this slope of this. And we know it is ending, like you can take any 2 points. Let's say we are taking this point here, which is corresponding to x equal to 8, and this point, which corresponds to x equal to 2. Okay? So here we go with the 2, which is the x2 minus, and then the upper part is going to be 8. And on the x-axis, this point is corresponding to 2 seconds, and that point was corresponding to 0 seconds. So 2 minus 0. Here we got it minus 6 and divided by 2. So we got it to be minus 3 meter per second. That's the V1 we got. Can you also tell what is the velocity at 3 equal to 3 seconds?
0.
That is 0 because it's a straight line and there is no change in the x. So the x is the same, therefore 0 divided by time interval is going to be 0. So once you know the 2 time intervals and the 2 velocities, you put them here and determine the acceleration. Okay? So it is going to be V2, which is 0, minus V1, which is 3, minus 3. So it's going to be minus 3. And here you have T2, which is 3, and T1, which is 1 second. So 3 divided by 2, and then it is 1.5. So the magnitude of your acceleration is 1.5 meter per second square from the graph. Okay, and this problem, just read the problem here, because you guys need to answer this.
Would you mind repeating the first one after getting the curve? After getting the tangent line?
You mean for the V1 or for the V2?
For V2. For V2.
V2. Okay. Here, when we want to determine V2, we want to determine the slope of the line. So you can choose any 2 points. Let's say you choose this point, which is corresponding to 3 time equal to 5, and you choose this point, which is corresponding to t equal to 1. Okay, you know the time interval. Can you tell what is the x here? Right here?
Yes.
Do you see my cursor on the graph here?
No.
You don't see my cursor?
No.
Oh, okay. I thought. Anyway, what is the x for corresponding to t equal to 5 seconds?
5.
It is for the 5 seconds. The x is 2, right? And how much is the x for the t equal to 1 second?
2.
2. So here when we say x2 minus x1, we say 2 minus 2, right? 2 minus 2 divided by 5 minus 1. So here in the numerator you got 0 divided by 4, and therefore your velocity v2 is 0. That's what the slope you get. You got it?
Oh, yes.
Okay. Okay, in this problem here, you have two objects, object A and object B. You throw these two objects from the top of a building with the same magnitude of velocity. Even though you've thrown one downward and one upward, but the magnitude of the velocity is the same. If you go for the sign, so one will have the positive velocity, another one will have negative velocity. But we are concerned about the magnitude here, so the magnitude is the same. Object A is thrown upward and object B is thrown downward. When they reach the ground, and we are ignoring the air resistance at all, what will be their speed? Do you think they will hit the ground at the same speed, or it will be a different thing?
Yes,
Yes,
they
sir.
will have
Yes,
the
yes.
same
The same
velocity.
speed.
The same
velocity.
speed, but different time.
Okay, so here the option A, it says that the two objects have the same speed when it hits the ground. Option B says object A has a higher velocity than object B, and then the other options you guys can read one by one. But you already answered that yes, they will hit the ground at the same velocity. So some students, if they are confused, look at the whiteboard here. I'm just explaining this trick here. If this is your platform, and from here you've thrown one ball upward and another ball downward, okay, downward here, and it is hitting the ground. The ball, which is the ball A in this case, it goes upward and come back. If it comes to the same height from which you have thrown it, it will have the same velocity, magnitude of velocity. If it was thrown upward with the 20 meters per second, when it reaches back to the same point, it will have 20 meters per second magnitude of velocity, but it will be just in opposite direction. So means when it starts its journey below the line, it will just go the same as the object B has went. Okay, so it will hit the ground. Both of them will be hitting the ground with the same velocity.
Doctor?
Yes.
If he asked me about the time will be different, right?
The time, the A is obviously taking longer because A is covering a journey upward as well, right? So it will be A will be taking longer than B. If the time was asked, yes, you say A is taking longer. If it was asked how long it takes, then they have to provide you initial velocities, the final velocities, the height, something like that. So you can calculate the data out of that. If they ask just descriptive question like is this is asked, in there they can ask qualitative answers. Qualitative answer means A will be taking longer than B. You cannot say how long it will take, right? Okay. Question 5. A ball starts from rest, slides down a hill with a constant acceleration for 10 seconds. If it travels 50 meters during the first 5 seconds of its motion, how far will it travel during the next 5 seconds of its motion? So here we look at the available data set. And based on the available data set, can someone tell me reveal the strategy of solving this kind of problem? What should be your first step you will be taking here?
We need to find the constant acceleration.
We need to find the acceleration. That's the first thing we want to do, right? So once we know the acceleration, afterward we will be playing with the second part and solving for the length. So here we begin with the equation, but also make sure that there are 3 equations of motion, and choose the equation of motion for which the variables exist here. Most of the variables exist. Okay, so which equation will you choose?
we'll find first the final velocity, then we compare it to the next. We compare it to the next line, the next five
Yeah.
50 or the next 5 seconds. Sorry.
Yeah. Okay. So what I mean by that whenever we are going to the to choose any equation of motion, we choose here the equation in which there is only one unknown, and therefore one equation can work for us in that case. If we bring the two unknowns, then we need obviously two equations of motion for that. So x equal to v naught xt plus half a t squared. If we choose that this is our equation, so we started with this equation and we know that the object is beginning its journey from rest, right? Starts from rest. So then the initial velocity is 0 in that case. And we also choose the first interval of time. They say if it travels 50 meters in the first 5 seconds. So they already revealed this 50 meter. And then here we have half. Acceleration is unknown, but we know the time. Should we take 10 or 5?
5 squared.
5 seconds. So here we take the 5 seconds. So therefore, when we are solving it for A, we multiply both sides with 2 and divide by 25. So A is going to be 100 divided by 25, which is 4 meter per second square. Now I will go with the total length, okay, because the acceleration is constant. So I will use the same equation again. It will be v naught x plus half at square. Now again, for the total journey, since we are considering the entire journey, so the initial speed is again 0. And now I know the acceleration. I put it 4. And here the total time for which it was traveling, it was 10 seconds. So I put 10 seconds and square it. So it will be 2. And then this is giving me 100. So I got total, in total, I got 200 meter, the total length. Based on this now, not proceeding any further, can someone tell how long, how much distance it will cover in the next 5 seconds?
150.
150. Because the total distance is 200, and the first 5 seconds it has covered 50 meter. So we just subtract, right? We look for that 200 minus 50, it will be 150 meter distance covered in the second part. Okay, this is a problem, guys. Focus here when we solve this problem, because I noticed that there are the questions like this look extremely simple when you look at them, but oftentimes students are prone to make mistakes here. So let me do step by step and try to understand what we are doing and how we should be handling this kind of problem. When you look at this this diagram, then what you have is that one of the vector, which is vector A, and it is making a 30-degree angle here, and this is our vector A. We know that it vector, when I'm using this angle, I can use this one, or I can use with respect to the x-axis. It is up to me. But here, since it is given, let's proceed with the given angle. Then I start to make the its components. So the one component, which is the y component, will be like this. It will be ay, and here this is the x component. Okay, ax. So when I'm making the two components, you already know that it is going to be ax, and the magnitude of the A, vector A, is 15. So 15, do you think that ax here, will it be sine or cosine?
Sine.
Sine. Sine 30 degree. And similarly, when I go for the y, it will be 15 cosine 30. Okay, that's one thing. And also we know that the AX and AY, they are both pointing in the positive X and the positive Y, therefore we are not considering any negative signs here. When I go to the second vector, which is the vector B, and this is making an angle 35 here, 35, vector B. So this is again the component like this for the vector B, which is BY, and here this is the BX. Do you see that the BX is going into the negative x-axis right here?
Yes.
Okay, so BX, when you are putting the BX, you can just use the unit, the negative sign right here, or you can also use it later on when you are putting this in form of the vector. So BX, here you have negative just because it is pointing to the negative x-axis. And the magnitude of this vector is 10, so I'll be using 10. And again, when you look at this angle, it is sine theta, right? So sine 53. And when I'm using BY, then it is pointing to the positive y-axis, so therefore it will go to the positive y. Magnitude is 10, and it is cosine 53. Okay. Now the last part here we have C. This is vector C. It makes an angle 20. And I need to make the components of the vector C. So this is the CX, and this is the CY. And if you look at again, that the CX and CY, both of them are pointing into the negative x-axis. So negative x-axis is the CX, negative Y is the CY. So therefore, I told you that the negative sign or the positive sign in this kind of equations does not come naturally unless you take the angles with respect to the positive x-axis. Okay, so you have to be cautious of that. This is 25. You have to be cautious, and you need to put the negative signs yourself. So CX, the magnitude is 12. Sorry, put the negative sign up front, 12. And then again here we are talking about this. So this is now, it is adjacent angle. So therefore it is the cosine 25. And for the CY, it is minus 12 sine 25. Okay. So everything is adjusted now. Now when we are looking for the resultant vector, so what should be the magnitude and direction of the resultant vector? First of all, we need to determine the resultant vector. Okay, so I'm leaving it here. Rx, I, all you need to do is to add the x components, Ax, Bx, and Cx. Then when you want to determine the Ry, then you just add the y component of x, A, B, and C. And then that will give you the y component. Okay, the magnitude, we are applying the Pythagoras theorem. And for the angle, when we are interested in the direction, then that will be tan inverse. Tan inverse Ry divided by Rx. So whatever the Rx you got here and Ry you got here, you put them in this equation, determine the angle. Do you guys have any question for me?
Doctor?
Yes.
In the A and B, can I subtract the theta from like A from 90 and I use 60 for A?
Yeah, it's a very good question. Yes. Here, when you subtract the angle, this 30 degree from the 90, and then this angle, it is going to give you 60 degree, right? 60. You got it?
Yeah.
When you got 60 degree, then when you are looking for the AX, all you need to do is the A cosine 60, and for the AY, it is going to be A sine 60. In this situation, if there was any plus and minus sign, it will come naturally. You don't need to be considering the negative, positive signs yourself. the equation will bring it. For example, for this one, the angle that B is making, it is 90 plus 35. So 90 plus 35, how much is it? Sorry, 53. 90 plus 53. So this is 3, and here we have 14, right? 143. So if I'm putting in the for the bx and by, again bx is going to be the magnitude of b cosine 143. Similarly, by is going to be the magnitude of b sine 143. And you will see yourself that the negative and positive sign will come naturally in the equation. You don't need to consider the positive and negative signs.
So if we convert all the three angles to be with respect to
with respect to the positive
x-axis,
yes. If you make all angles with respect to the positive x-axis, first of all, you don't need to consider the negative positive sign. Second, the cosine and the sine will remain as we are mostly using them.
Okay.
Yeah.
Doctor.
Yes.
How did you know in the figure that the first where is vector A and B and C?
Because they are saying the vector B and vector C is given here, right? Vector B, vector C is given, and they are talking about the vector A, vector B, vector C. So here, in this figure, they just forgot the vector A to write here.
Oh, I didn't see that.
Yeah. But
Doctor,
they will be there.
Doctor, how did we? What is the answer of the sum of the white components?
You just add them, like as we determined that, right? I just erased them. But once you have them, x, y, z, then you add them. Like there is this answer. Like this is the ax, bx, and then again the sorry. Yes, ax, bx, and this is the cx, right? And then ay, by, cy. When you determine that, then this is the rx, sx in this case, this is the sy. Okay. Okay. Coming to this one, this is a very good problem. Can someone comment on this?
Doctor?
Yes.
Sorry for interrupting you, but can you go back for the previous question? I want to know the answer.
You want to write it?
Okay, which one, B or A or C or D? Or
A. Option A is the answer.
Okay, yeah. Okay.
You need to determine the magnitude, right? And
Yes.
then answer the angle. Yes.
I got you.
No, I think it's B, Doctor.
What is that?
It's for the Y components, the question.
Uh-huh.
It wants the Y components, the question.
I didn't get.
If you go up, I think it says go up more.
Yes.
The Y component, so it's B.
Oh. So you say that this one, right? Okay, yes.
I don't see the necessity of the angle.
Yeah,
But,
this is exactly. So since you're you pointed, I thought I overlooked this problem at the end. Yes, since they are looking for find both the magnitude and direction of the resultant of these vectors. Okay. So first of all, you need to determine that, and then also it says that the y component of the sum of the vectors is. So here, this is in a way, the problem is really not worded correctly. Okay, there is a issue in the problem because they're asking two things, and they are providing an answer for only one thing. So yes, you need to look at the problem. If they were asking for the magnitude and direction of the resultant vector, then this is the resultant vector. Okay, this is the magnitude you need to determine from here, and then also apply the tangent theta to determine the angle for that. Okay, for the y component, if this was the second part, y component of the sum of the vectors, then yes, you're right. It is like 13.94, and if they're rounding it, it will be 14. So then you check this 14, which is the answer, and then the y component, it doesn't make any angle with respect to x-axis. Like it is making the y 90 degree because the x are pointing in x direction and y pointing in the y direction for the resultant. Okay. So you will be looking at that, like how in which quadrant your vector is lying, and then based on that, your x and y angles you can decide based on that. But the problem is a little bit wording is misleading. Okay, so this is a very cute problem again. Can someone tell how can we solve this one?
Yes.
Yeah.
Find the magnitude.
Okay.
Find the other vector which makes it 0.
Okay, so here we are going to use the definition of the unit vector. What is the magnitude of a unit vector?
1.
1. Okay, so that is the definition we want to use. Vector A is equal to B times 3i plus 4j. Okay, so when you want to determine how much the B is going to be in order to make vector A a unit vector. So we know this, that whenever we are talking about the vector A, if this is my vector A is consists of two things. One is the magnitude, another is the unit vector of A, okay? Magnitude times unit vector of A. This is how the product we are writing. So we divide both sides by the magnitude of A, like this, okay? And here we bring the A. If I'm interested in the unit vector, I will have the vector A divided by its magnitude. That will give me the unit vector. When I look at here, I do see this. This is the vector. This is also part a scalar quantity. But how much it is to make this vector a unit vector, then all I need to do is to determine the magnitude of this quantity here, okay? And the magnitude is going to be 3 square plus
5.
4 square, and then this is giving me 5. So once I get the 5, which is the total magnitude, so I will bring this into the denominator, right? So in the denominator, like this B is a denominator, and I want the 5 to be in the denominator, so therefore the B is going to be 1 divided by 5. So using this equation and combining that with that equation, I see that it is the 3i plus 4j divided by 5. It will give me the unit vector. If you are still not convinced how it is going to be, then you determine that the magnitude of the top, which is obviously 5, so 5 divided by 5 is giving me 1, which is the definition of a unit vector. Okay. Two vectors, vector A and B, have magnitudes 3 and 4. Their vector product is A cross B, which is given here. Find the angle between A and B. Please tell me what should we do here?
We can use the equation
Yeah.
A vector B is equal to the magnitude of A multiplied by the magnitude of B sine theta.
Sine theta, yes. So that is what we want to use. So A cross B equal to A B sine theta, and then there will be a unit vector N. But since we are all interested in the magnitudes, so therefore we are putting a modulus here, and then remove this N from here, the vector quantity altogether. So since the angle is here, I will need to determine, so divide both sides by AB, and take the inverse sine. So the angle we get is going to be inverse sine A cross B magnitude divided by AB. Looking at the problem, we know the magnitude of A, we also know the magnitude of B. Can we determine the magnitude of A cross B?
Yes.
Yes.
Okay. How to determine that?
Pythagoras.
Square root for 5 squared plus 2 squared.
Exactly. So A cross B square root, the magnitude is going to be, we have the vector K, which is 5 square for the 5 plus 4. Yes, 2 square. Okay. So we get the magnitude of AB from here, A cross B. AB magnitude 3 and 4, we know it. Once you put them in this equation, determine the angle. Any question here?
Yes, at the start you put the n next to sine theta.
I put the vector n because you know by definition A cross B is a vector product. It is also called vector product. So when you multiply A with the B with the cross, then you are going to get a vector. So the vector, the unit vector, when I put, that is definitely a vector. So if you make a cross product at the end, you are getting the vector, like as you are seeing here. A cross B, it is equal to a vector, which is minus 5k plus 2i. Yeah.
Yes, so the n is a vector?
Yeah, n is a vector which will be perpendicular to the planes of A and B. And you can determine the direction by this hand. Remember that I showed you how to use your hand, like right hand, right? So if this was your vector A and your palm is the direction, like the marker you are seeing here, if this was the direction for the vector B, then the thumb right here, this will be giving you the direction of A cross B, which you see it is perpendicular. There is a 90 degree or whatever the degree you have. But when you have this is a plane, like the board, this is a plane. So this thumb is out of the page, okay, towards you. So that's how you are going to get the angle by using your right hand.
Doctor, what is the answer? Is it 90? Is it 27?
Yes.
Doctor, when I have k squared or I squared or j squared, are they gone?
What is that?
If I have k squared or I squared or j squared, I eliminate them, or what I do?
Remember that when we are determining the magnitude, if you look at the total formula of determining magnitude, if you have a vector which is 2i plus 3j, basically what is happening, what we do is that we take the dot product of A with A, okay? A dot A, which is A cosine, and since this is the same vector, so therefore the angle between them is 0. And then on the right side, we also take the dot product. So you guys remember that the I dot I is 1, J dot J is also 1. So 2 times 2 I left with, 2 times 2 will be square, and plus 3 times 3 will also be square. Okay? So here what I got, it is A square, cosine 0 is 1. On the right, I have 2 square plus 3 square. And then when I want to determine the magnitude here, so I take the square root on both sides. The square is cancelled from there, and I get the square root on the right side. This is the total formula for determining the magnitude. Okay? And you see that the I dot I, which you mentioned, that I dot I, it go out. It is equal to 1. Just read the lecture slides which I posted, and then I provided extended formulas for the cross product as well as for the dot products of these. Okay. There is one good problem, which is this one. So before going into that, and definitely I want to finish that product because it's a very good problem. Here I'm posting. This is in the comments, I posted a quiz. Go ahead and do the quiz. 1 minute. Okay. Just take 1 minute then and come back. Did you do it?
I'll wait a little bit, Doctor, please.
Where can we find it, Doctor?
Yeah, in the comments there is a link. Go click on the link. Go ahead.
Just a minute.
Sir,
Yes.
if I did it, can I leave or we
No,
will...
we are still solving the problems. The
Oh,
class is
okay,
not
okay.
working.
Okay.
This one problem I really want to solve this, and you guys need to understand it because the pattern of this problem is completely different that we touched so far. So
Okay.
it's a good problem. Yeah. Okay, so guys, I'm closing the link to the quiz. Okay. Just complete your response now. I'm closing the link.
Wait a minute.
Doctor.
Yeah.
I got 2 out of 2.
It's fine. Yeah. It will be recorded. Okay. Done? All right. So I'm closing the link, guys.
Doctor, where I can find it? I didn't find it.
What is that?
Where I can find it? I didn't find it.
In the comments box. In the comments, just there is a link. Click on the link.
Sir, is it graded or just for practice?
It's graded. Did you get the points?
Does it tell me that I need to sign in to the...
I don't know. You guys are so complicated. Why it doesn't tell this everyone else? Why it only tells you to sign in? So you are obviously doing something wrong.
Doctor, have you finished the lecture?
No. This is one last problem I want to solve. The students who are done with the quiz as well as with the attendance, they are free to leave. The students who want to stay with me, I will be spending 3-4 minutes on that problem, and will end my lecture after that. Okay, but the lecture is officially over now.
Doctor, it is graded that these 2 questions?
It's a class participation. In the class participation, it will be counted. Okay.
Doctor, sorry, can you open it?
So this is the last problem, guys. A player running in an open field has components of velocity Vx and Vy at t equal to 10 seconds for the time interval from t equal to 10 seconds to t equal to 20 seconds. The magnitude of its average acceleration is 0.45 meter per second squared, and makes an angle of 31 degrees with the positive x-axis. Find the velocity in units meter per second of the player at t equal to 20 seconds. So this is the first time we are seeing that the acceleration is given in its magnitude and an angle. Okay, this is the first time we are seeing it, and we need to determine the final velocity. So the velocity obviously is a vector, and we need to determine the x component, y component, and then bring them together. Okay, so here we want to determine the x component of the y component of the acceleration first. What will be the x component of the acceleration?
It's times cosine 31, the acceleration time.
So it will be a cosine theta. So a is 0.45 meter per second square, and cosine, the angle is 31. Similarly, for the AY, it is going to be the same way, but now sine theta. So 0.45 sine 31. Okay. This is, we are getting the X and Y components. Now I'm interested to proceed to determine what is the X and Y component at the end of the time, which is 20 seconds. So Vy, you guys remember that we used to do, let's begin with the X. So we used to say this, we are solving the problem for the Vx. You have the initial velocity plus X component of the acceleration times t. And similarly, if you want to proceed with the Y component, it will be also the same thing. So here we know that the initial component of the velocity is 2.6 plus the X component of the acceleration is this, which is 0.45 cosine 31. But another question apart from this, which is new, I also ask here, how long we are going to use? What will be the time interval we are going to use?
20.
You see, this is the problem.
10.
This is the problem, guys. Whenever you see this kind of problem, the velocities which were initially discussed, they were already at t equal to 10 seconds. So after the t equal to 10 seconds, the time passed until 20 seconds, it is only 10 seconds. So the time interval you are going to use here, it will be 10 seconds because that's the time interval from 10 to 20. Don't put 20, okay? So this is another complication here. So once you know this, the Y component is extremely simple, the same way, V naught Y plus AYT. And you use the Y component acceleration and the initial velocity which is given there, okay? And the time interval will be again 10 seconds. You know X component, Y component, put them together to get the velocity. I'm open to your questions, and the students who wants to leave, you can leave now.
Doctor, is this chapter 4 question?
What is that?
This question number 9.
Yeah, it's the chapter 4 question because here we have 2 dimensions like X and Y components, yes.
Doctor?
Yes.
Where can I find this PDF?
This is one of the old major 1 exam. Do you know how to determine, find out the exams on the website? Physics 101 website?
No.
Okay. Let me send you the link in the comments to that website.
Doctor, about question 7.
Yeah.
I didn't understand it.
In the okay, so I send you the link in the comments. That is a link to the major 1 exams. You go there, you find the major 1 exams and the solutions for the exams as well. Try to solve some problems from there to familiarize yourself with the patterns. Okay, your question, you didn't understand question 7?
Yes.
Okay. You mean this one?
Yeah.
Okay. It says that vector A, which is the B times other quantity, where B is a constant. Find the value of B that makes vector A a unit vector, okay? Yeah. So by definition of the unit vector, we know the unit vector, like I is a unit vector, J is a unit vector, K is a unit vector. So definition of the unit vector is that it has a magnitude 1. It just only shows us the direction. And if you want to determine the magnitude, it has to have a magnitude of 1. So that is the that is said. Have you ever thought that when we determine the angle using the tan inverse, we are getting the direction, right?
Yes.
Okay. When we get the direction out of that, let's say the angle you got was 45 or something, 45 degree. And
Yeah.
then for that vector, when I'm getting the unit vector of that, it will be cosine 45 I plus sine 45 J. Okay, something like that.
Okay.
Do you know when you take the magnitude of the unit vector A, you will get it to be x squared, right?
Yes.
Plus sine squared. How much you get by trigonometric functions?
Cosine square of
Sine cosine square theta plus
is
sine
1.
square theta. It is equal to 1, right?
Yes.
Okay. No matter what the angle, the argument is, at the end you are going to find the answer 1. Under square root and then under square root again, you get 1.
Yeah.
So whenever we determine any angle, that means that we are looking for the direction in for that vector. Here again, the problem tells us the same thing. It says make vector A a unit vector. So if I know a vector A, let me approach this problem from a little different angle. Vector A is there, 3i plus 4j. I'm not writing B. At this point, not writing B. I want to determine its magnitude. Magnitude, we determine it to be 3 squared plus 4 squared under
5.
square, which is giving me 5.
Yes.
If you remember that I also said that the vector is a combination of the product of the magnitude times unit vector.
Yeah.
If I divide both sides by the magnitude, I will get the unit vector here. So this vector, vector A, which is here, 3i plus 4j, and divide by the magnitude, which is 5. Okay? That's
Yes.
what I got. Now, this is a unit vector. If you take the magnitude of this, it will give you 1. So by definition, it is correct. Everything for the unit vector, it is correct. Now, I make the comparison of this equation, which I derived, with the equation shown in the problem. So which is the A equal to B times 3i plus 4j. When you compare this equation with this, what do you get? What is the value of B?
Yeah, it's 1/5.
1/5.
Yeah, it's clear now. Thank you.
Okay. Okay, no problem. Okay, guys, I have another meeting starting now. Otherwise, normally I have 1 hour office hours at this point. But today, the department placed a meeting which is unannounced. So I need to join that, okay?
Okay, thank you, Doctor.
Yeah.
Doctor, I want to
Yes.
discuss some things with you. When can I do that?
This is about what? This is, can you tell something?
Yeah. About the exam that we had just now, for one. That's one of the things.
This example?
No. The 2 questions that you gave us. About
Okay.
it being graded. Yeah, I don't see why they should be graded when I didn't know they were even graded. I thought this was for attendance, to be honest. Because many doctors.
These are the class participation. Okay, it is like if you look at these are the 2 points I provide them, but the entire class participation we are looking at it. Okay.
Yeah, but Mister, when I signed in, it told me to put my email and password. After I put, I answered my questions and pressed submit, and then told me the form is closed. And I have my answer already, but I can't submit.
Okay, I can open the form for you. Yes.
I find it absolutely fair, Doctor, for you to ask us. But if I don't know it's graded, and I just answer anything, and then when I finish, I found out it's graded, it's not very fair, if you ask me.
So you should not be putting anything right there. It's not the filling the blanks, right?
Yeah, but Doctor, everyone does that. Every other doctor,
Okay,
when he
also,
goes for a dancer, he does it.
Were you here with me from the beginning of the semester?
Yes.
Okay.
Not from the beginning.
Okay, were you seeing some the checkpoints are popping up once in a while?
Yes.
Okay, it's the same thing. It is exactly the same thing. I used to pop up the this kind of very simple questions like this, right?
Oh yeah, I thought they were for attendance. That's the thing. This is to my surprise. This is news to me.
Okay.
We used to do this in chemistry.
Do better in future, and then I will choose the best. Okay.
Okay, sounds good. Sounds good to me.
Okay.
Sounds good.
Abdulaziz, did you do it?
Yeah, I already submit. Thank you, Doctor.
Okay. Fahad, what's the question?
We have an office hour this week.
Office hour was my normal office hour. I'm having another meeting, but I can postpone this office hour from 2 to 3. If you come at 2 o'clock, then I should also be.
It's fine, but do you have the solution for this exam? I want the first 2 questions. I didn't get it.
Okay, so I can upload the exam to the Blackboard. Okay.
Okay, it's fine. Sounds good.
No problem. Yes. Okay, so you don't need to meet with me afterward, right?
Yeah, it's fine. No problem.
Okay, then that's fine. Okay.
For me too, Doctor, because I have a class at 2 to 3. So I have something very quick. For the exam that we had.
Meeting already started, guys. I'm 3 minutes late for that meeting. It's a departmental meeting. Okay.
Okay, so, you can.
Yeah, send me something in email, and I will try to respond to you.
Okay. Send the solution, Doctor.
I'm uploading this. Yes.
Okay. Thank you.
Yes. Assalamu alaikum.